Okay, good afternoon, all. So, from this session, we are starting our next chapter, that is Introduction to the Powder Metallurgy. So, before starting the chapter, we will see what are the contents in this chapter. In this chapter, first we will start with the what is the meaning of the powder metallurgy, then what is the importance or significance of the powder metallurgy process in your metallurgy subject. Then different steps involved in the powder metallurgy technique to manufacture a particular product. Uh, then different types of the powder manufacturing techniques or powder production techniques. Uh, these mixing, blending, all these are just steps which are involved in the powder production. Uh, manufacturing a component using the powder metallurgy technique. And then after that, we are going to take the a few practical examples of the products which are manufactured with the help of this powder metallurgy technique. In that, we are going to take three components. First one will be self-lubricating bearing, then cemented carbide cutting tool, and friction material. The in examination, two questions will be there. One question will be from this part A, and one question will be from this part B. Compulsory one question will be asked from these three components. They will provide you name of one component, and they will ask you to draw the flow chart, and along with that flow chart you have to explain the different stages involved in the manufacturing of these components using powder metallurgy technique. Or the second question will be from this part A. Here either they will ask you the which are the methods used for powder production, or they will ask you the stages in the manufacturing of the component using this powder metallurgy technique. And some questions will be related to the advantages, limitations, and applications of this powder metallurgy process. So two questions will be there. Approximately 13 to 14 marks will be there. Then what are the prerequisites? These are the prerequisites to understand this chapter. Uh, all these are prerequisites. It will involve engineering chemistry, then workshop practices, then some manufacturing processes. A reference will be there. Largely, it is based on only this engineering chemistry. Okay. First, we will start with the concept of the powder metallurgy. Now, what is the meaning of the powder metallurgy, or what we are going to do exactly in this powder metallurgy process? Now, this powder metallurgy process consists of two parts. The first part will be manufacturing of the metal or non-metal powders. That will be the first part. And second part, whichever metal and non-metal powders we have manufactured, using that metal and non-metal powders, we are going to manufacture a particular component according to our desired composition and according to the desired shape and size. And during that, we are going to follow the different stages in that. Okay. So, in short, this powder metallurgy process, I have this is the definition. That is, it is a branch which deals with the production of metal and non-metal powder. Okay, it will be divided in the two parts. Powder metallurgy will deal with production of the metal and non-metal powders, and whichever powders we have manufactured, it may be metal or it may be metal plus non-metal. Using that composition or combination, we have to manufacture the component by following certain steps. It will be termed as the powder metallurgy. Okay, powder metallurgy is a branch of metallurgy which deals with production of metal and non-metal powders, and subsequently manufacturing a component using these powders. Okay, this is the meaning of the powder metallurgy, or these parts we are going to discuss in this chapter. Okay, first part will be how to do the production or manufacturing of the metal and non-metal powders. That will be our first part. And in the second part, whichever powders we have manufactured, with the help of that powders we are going to manufacture the actual component using different combinations or different compositions of different metals, and it may be combination of different metals, or it may be combination of different metal plus non-metals. Okay, that we are going to discuss, or that we are going to study in this powder metallurgy chapter. Now, the second point is that whichever steps are there, that here they have highlighted that powder metallurgy components can be manufactured with the help of either metal powders or metal and non-metal powders combination, and you have to follow certain steps. That certain steps I have highlighted in the next slide. So these are the steps which we are going to use. Okay, generally any powder metallurgy technique, or while manufacturing any component using powder metallurgy technique, following 6 stages will be there. I have highlighted that stages here. First step will be powder production. Then second stage is blending or mixing. Third stage is compacting or pressing. Fourth stage is sintering. Fifth stage is sizing or machining. And sixth step is testing and inspection. Okay. On these different stages, I will conduct the next lecture will be based on these different stages, and this is the general diagram. Okay. This is the first stage, that is the manufacturing of the metal powders. Then mixing or blending. After that, we are doing the compacting process and sintering process. Then these are some machining operations or sizing operations will be there. And after that, we will get the finished product. And on this finished product, we are going to perform some testing and inspection operations. Okay. So these are the stages involved in the stages, or you can say the steps in the manufacturing of the component using powder metallurgy technique. I will take the next lecture on this steps in brief. I will explain each step in brief. So our first stage is the powder production. Okay, production of the powder. On this, I will today's lecture will be based on this only. That is the how we are going to do the powder production or powder manufacturing. Now I will start that. This part we will see in the next lecture. So this is today we are going to deal with this. Please. So whenever you are going to manufacture any kind of the product using powder metallurgy technique, your first stage will be manufacturing of the required powders. Okay, and for manufacturing of that required powders, we can use following methods. Generally, there are four methods to do the powder production or to do the powder manufacturing. Four methods are there. And that first method is you can say that mechanical method or mechanical processes. And second method is physical processes. Then third type which you can use is the chemical processes, and fourth is the electrochemical processes. Now these processes has further classified in different types depending on the principle used in that process. The mechanical processes are classified in six different types, as machining will be first type, then crushing, milling, shooting, graining, atomization, or in some books it is also mentioned as atomization or atomization also. Then this physical processes, there will be two types: condensation process and thermal decomposition process. And third is the chemical processes. In that chemical processes, three powder production methods are there. First is the reduction method, then intergranular corrosion method, and the third method is precipitation from aqueous solution, or it is also known as simple displacement method. And the final or fourth method is electrochemical process. Okay. Now, depending on the shape and size, depending on the shape, size, or on the nature of the distribution of that powder, you have to select the suitable method. Okay, depending on the desired shape and size of that powder particles or distribution of that powder particles, you can choose any one method from these four methods depending on the shape and size desired. Okay, now uh, before we will start the brief description or brief discussion related to this. Please draw this chart. I will wait for a few minutes here. Please draw this chart along with its brief classification. Please draw it, and after completion, please mention that in the chat box. I will wait for only 1 or 2 minutes. Please draw this chart. Okay, now we will start the brief discussion related to the different processes which we are using for the manufacturing of the powders, which we are going to use for the manufacturing of the actual components using powder metallurgy technique. Now, in this first method or first process which we are going to use is mechanical processes. In that mechanical processes, the first type is the machining process or machining method we are using for production of the powder. Now, in this machining method, what we are doing here, the suppose whichever metal powder you want to manufacture, that particular metal is taken in the form of bar, sheet, or rods, whichever form it is available. In that form, that material is collected, and simply we are going to perform a machining operation on it, and the powder is obtained in the form of chips, or you can say that filings or turnings. Whichever filings, turnings, or chips are obtained after machining that particular material, that will be our powder form obtained. Okay, just you have to collect that material in the available form, and you have to simply perform a machining operation on it, and whichever chips or you can say that turnings, filings are obtained at the end of that machining operation, that are collected as the powder. Okay, as the obtained powder at the end of this machining process. Sometimes you can perform the crushing operation on it. Okay, whichever chips or turnings or filings are obtained at the end of machining, to get the desired shape and size of that powder, you can perform the crushing operation also. Okay, now generally with help of this machining process, whichever powders are obtained that are irregular in shape. Okay, its shape and size is irregular. Okay, in each process you have to mention how that process is conducted and which type of the shape and size of that powder particle is obtained, and you have to mention few examples. Okay, for each process while explaining the each method of powder production, you have to mention in the first sentence how that process is conducted. In the second step, what will be the shape and size of that powder particles, and in the third step you have to mention few examples. Now, machining process I have explained. Now, whichever shape will be obtained at the end of machining, it will be irregular. Irregular shaped powder particles will be obtained in this machining process. And you can, for example, you can say that for machining, magnesium powder can be obtained. Magnesium powder, then you can say that iron powder. These are manufactured magnesium, iron. These powders can be manufactured with the help of machining process. So this is the first type which is used for the production of the powders. Then the second type is the crushing process. Now here, so the material is taken from which you want to manufacture the powder. It may be available in the rod shape or rod form or bar form, or it may be in the plate form. That material is taken, and simply we are going to perform a crushing operation on it with the help of different types of the hammers or different types of the jaw crushers are there. With the help of that, that material is simply crushed, and automatically it will, due to that crushing operation, this process will be termed as crushing operation, and automatically due to this crushing, that material will get transformed to the powder form. And in this crushing process, depending on the type of the material used, depending on the type of the material means nature of that material, you will get the powder shape. Okay, if suppose you have used the brittle material, then whichever powders are formed, they will be angular in shape. And if the material used is ductile, then the powder forms will be flex shaped. Okay, depending on the material used, different shapes of the powders are obtained. If material is brittle, you will get the angular shaped powder particles, and if material is ductile, then you will get the flex shaped powder. This is the crushing method. Simply you have to collect the material available available in the different forms, and you have to use the different hammers or jaw crushers to crush it, and you will get the different sized powder particles depending on the nature of that material. So this is the crushing operations. Now in this crushing operations, you can mention the examples of iron, zinc, nickel. These are the few examples. These metal powders can be manufactured with the help of this crushing operation. And then the third mechanical process which is used for production of the powders is milling process. Okay, third process is the milling process. In this milling process, what we are going to do, just we are going to take one steel container will be there, a stainless steel container or stainless steel drum will be there, and in that drum we are going to take the material from which we are going to manufacture the powder. That material is taken along with some rod mills or ball shaped mills are there. Okay, rod shaped or ball shaped mills, and the material from which we are you are going to form the powder, that is taken in a stainless steel container, and we are going to rotate that stainless steel container. Okay, you are going to just rotate it, or you are going to perform the tumbling of that rotate that drum or that container. Due to that rotatory operation, what will happen inside that drum, the whichever material is present, it may be in the rod form or bar form or in the plate form, it will, and in that rod mills, collision will be there. Okay, due to that collision, the metal will get separated from that source material, and powder will be obtained in that drum or steel container. Okay, and at the end you can separate that powder. Okay, simply I will repeat it again. In the milling operation, the material which whose powder you are going to manufacture, it is taken in the form of a rod or in the form of a bar or in the form of a plate, along with hard and you can say that hard rod mills or ball shaped mills will be there, or disc shaped. Okay, just hard balls will be there or hard discs will be there along with that source material, and these two will be taken in a drum, stainless steel drum, and that drum is rotated with very high speed. Due to this rotation, what will happen between that mills, rod shaped mills, disc shaped mills, and the source material, collision will take place, and due to that collision, material will get removed in the form of powder. And at the end of this process you can remove it. Now this milling process can be performed in two ways. The first is the dry method and second is the wet method. Whichever process I have explained now, that is the dry milling method, and in the wet milling method same process is conducted, but while in that drum we are going to add certain liquids like alcohol or acetone or some stearic acid. These elements you can use. You have to either go for alcohol or acetone or stearic acid. Why we are using these liquids? They will help for faster removal of the powder. Whichever powder is formed, it will get removed at a very faster rate due to this presence of this liquid. Okay, whenever you are using this liquid, that method will be termed as weight milling method. Okay, that method will be termed as the weight milling method. So this is the milling process, and it will be conducted, it can be conducted in two ways: dry milling method and wet milling method. Now whichever powder is obtained in this milling process, it will be irregular shaped powder. Okay, irregular shaped powder will be obtained in the machining. In the milling also irregular shaped powder is there. Just in the crushing, depending on the material, powder shapes are there. Then uh, you have to mention some applications or metal powders that can be manufactured with the help of this milling process. Now for this, whichever carbide metals are there, that carbide metals can be formed with the help of this milling process, or different, you can say that iron powder, zinc powder, then iron powder, zinc powder, then nickel powder, copper powder. All these powders can be manufactured with the help of this milling process. Then next process is the shooting. Now shooting and graining method, these are having little bit similar concept, just there is a little difference of the medium used. Okay, shooting and graining, I will explain it in together. I will explain these two processes simultaneously. Now whichever these three processes are remain: shooting, graining, and atomization. In some cases atomization is used, atomization. And if you search on the internet or if you are using any other books, you will find that they have used the name atomization. U is eliminated. Atomization. Okay, because they are separating the atoms. From that, they have given the name atomization also. Okay. Now, in these three methods, in these three methods, we are using the molten metal. Okay, in these three methods we are using the molten metal. In first three methods we have used the source metal in the form of, in the solid form, and in these three methods we are using the source material from which we are going to obtain the metal powder. Okay, we are using the source material from which we are going to obtain the metal powder. uh, we are going to use it in the molten form. Okay, now This is the significance of these three processes. Now, in the shooting method, what we are going to get here, or what we are going to do here, now source material of that metal is taken, or the whichever metal you want to manufacture, it is taken in the form of a rod, or in the form of bar, or in the form of plate, and it is transformed to the molten form. Okay, it is melted, or it is transformed in the molten form, and that molten metal is poured on a vibratory skin. That molten metal is poured on a vibratory screen. Okay, one vibratory screen is there, which is having some outlets. Some outlets will be there, generally circular or spherical shaped outlets will be there on that vibratory screen. Okay, metal is taken in the molten form, and it is poured on that vibratory screen. That as that screen is vibrating, that and it is having some outlets, that molten metal will come out from that outlets, and when it is coming out from that outlet, with the help of suitable medium, it is cooled. Okay, it is cooled. Now, when the metal used for cooling that droplet is air. Okay, medium used for cooling that droplet is air, or you can say that simply any kind of the neutral gas, then that method is termed as the shooting. Okay, that method is termed as the shooting. And if you have poured the molten metal on the vibratory screen, and that molten metal is coming out from that outlet, and that droplets are cooled with the water medium, then that method is termed as the graining process. That method is termed as the graining process. Okay, in shooting and graining, remaining procedure is same. Molten metal will be taken, and on vibrating screen it is poured. That vibrating screen has some outlets, having circular outlets. From that circular outlets, molten metal droplets will come out, and these droplets will be cooled with the help of air medium. Then it is termed as shooting. And if the droplets are cooled with the help of liquid medium, then this process will be termed as the graining process. Okay, this process will be termed as the graining. Now here, in these two processes, the shooting and graining process, the shape of the powder particles obtained is spherical. Exactly or approximately spherical shape is obtained, because you can control the shape by using or by providing the desired shaped outlet on that vibrating screen. Okay, you are pouring the molten metal on that vibrating screen, and from that vibrating screen droplets are coming out. If you give the circular shape there, you can get the circular shape or spherical shape. So generally spherical shape is desired, and using these two processes you can get the exactly spherical shape. Okay, exactly spherical shape can be obtained using this graining and shooting method. Now, after this, the next method is the atomization. And for this technique, here also we are using the source, that metal in the molten form. Okay, this is the process, that atomization process. Here, this atomization process has different types. There is no need to explain these types. Just you have to understand the concept here. These types are depending on the medium used for doing that atomization. Now, how this atomization process is conducted, there will be one chamber. In that chamber, you are taking the metal in the molten form or melt section, and that melt, one outlet will be provided at the bottom end, and from that bottom that molten metal will come out. And exactly at this point, these molten metal particles are disintegrated means these are separated from that molten metal by with the help of a water jet, or with the help of gases like argon, nitrogen, or helium. In short, you can say that these are separated from this molten metal with the help of high pressure water jet or with the help of uh, inert gas, and the powder shaped particles are obtained at the bottom. Okay, metal droplets will be obtained at the bottom, and after completing this process you can remove this powder. Sometimes you can provide some one outlet is provided at the bottom also. Directly this powder is removed from the bottom. This process is termed as the atomization or atomization also. And generally, powder shape obtained in this process is circular or spherical in nature. Okay. In all these three processes, shooting, graining, and atomization, powder shape obtained is circular or spherical in nature. Okay. You can use it for manufacturing of the copper, then you can use it for manufacturing of the zinc. Okay, copper, zinc, then you can use it for magnesium. Okay, then nickel. But you cannot use it for manufacturing of the refractory metals. Refractory metals means the metals having very high melting point above 1500 degrees Celsius, like tungsten, molybdenum, then thorium, titanium, or the metals which we are using in the manufacturing of the filaments which we are using in that bulbs. Okay, that filaments are generally manufactured with the help of the refractory metals. That refractory metals having very high melting point above 1500 degrees Celsius, sometimes 2000 degrees Celsius also. Okay, above that. That's why the shooting, graining, and atomization method is suitable for manufacturing of the metal powders having lower or medium melting point, generally less than 1500 degrees Celsius. You can use it for manufacturing of copper, then nickel, then iron, and these powders can be manufactured, or you can manufacture calcium, magnesium powders also. Okay, so in this way we have completed the discussion related the mechanical processes of manufacturing the powders. Okay, 6 mechanical processes are used, and in each method what you have to explain how that method is conducted, or just you have to mention the procedure. Then in the second point, you have to mention the shape of the powder obtained. And in the third step, you have to mention few examples. Okay. So in this way, we have completed these mechanical processes. The next type of the powder manufacturing method is physical processes. Okay, physical processes. Now, in these physical processes, we have two different types of manufacturing the powder. The first is the condensation. Okay, first method is the condensation method. Now, simply in this condensation method, okay, in this condensation method, what we are going to do, just here we are going to take the metal vapors whose powder you want to manufacture. That metals are taken in the form of vapors, and a condensation or a cooling process is performed on them, and they are transformed to the powder particles. Okay, generally this condensation method is used for highly volatile metals. Highly volatile metals like magnesium, zinc, cadmium. These are highly volatile metals. Okay, highly volatile metals because they can be easily transformed. This zinc, magnesium, cadmium, these can be easily transformed to their metal vapors. That's why for manufacturing of their powder, this condensation method is used. And generally the shape of the powder obtained is spherical in nature during this condensation. Okay, shape of the powder obtained here is spherical in nature. Just the metal vapors are collected and they are condensed or cooled. They are condensed or cooled, and we will get the spherical shaped powder here. And for example, you can say that zinc, magnesium, cadmium powders, metal powders are manufactured with the help of this condensation method. Then the next type of the physical processes is thermal decomposition method. Okay, thermal decomposition or this thermal decomposition is also known as gaseous pyrolysis. Okay, this process is also known as gaseous pyrolysis. How this process involves some chemical reactions, or that I have added one slide here. Okay, this thermal decomposition process. In this thermal decomposition process, generally you can get the spherical or irregular shape. But here I have explained this thermal decomposition or gaseous pyrolysis method with help of two examples. That is manufacturing of the iron powder and manufacturing of the nickel powder. How this process is conducted. Okay, we will see these examples of iron and nickel. Now, initially, initially that metals are taken and carbon monoxide gas is passed through that metals. Okay, metals are taken and carbon monoxide gas is passed through it. Okay, at 200 to 270 degree celsius. Degree celsius, okay, this is the temperature in degree celsius, 200 to 270 degree celsius temperature, and 70 to 200 atmospheric pressure. Okay, carbon monoxide gas is passed through the iron powder. Here directly we are using iron powder or nickel powder, which is obtained by the machining operation. You can use by machining operation or any operation, any mechanical processes, crushing, machining. Okay, from that whichever powder is obtained, that metal powder is collected here and carbon monoxide gas is passed through that. And here we are getting respective carbonyls. This FeCO5 is iron carbonyl and NiCO4 is nickel carbonyl. Whichever carbonyls elements or material chemicals are formed here, these carbonyl chemicals are highly volatile in nature. Okay, these are highly volatile and they get decomposed at 150 to 400 degrees Celsius temperature and 1 atmospheric pressure to form respective powders. Iron carbonyl will give iron powder and nickel carbonyl will give the nickel powder, and carbon monoxide gas which is released, it can be recirculated or recycled and it can be used again and again. Now here this iron powder obtained here, you will get the exactly spherical shaped iron powder, and whichever nickel powder is formed, it will be having irregular shape. Okay, in this way this thermal decomposition method or gases pyrolysis technique is used for production of the powders, and this is used for manufacturing of iron, nickel, tungsten, molybdenum, cobalt, magnesium powders. And a few examples I have explained here. Manufacturing of iron and nickel powder. Shape obtained is, for iron it is spherical, for nickel it is irregular shaped. Okay, but here the purity of this powder formed will be very high. Okay, purity will be very high in this case. This is the thermal decomposition or gaseous pyrolysis technique. Okay, this is the second method of powder production. Then we will move towards the third type, that is the chemical processes. Okay, in the third type, three types of the chemical processes are there. In that, just chemical reactions will occur. Reduction process is there, intergranular corrosion is there, and third is just the precipitation from aqueous solution, or you can say the simple displacement. Okay, I will explain it from the bottom. I will start with this precipitation from aqueous solution. Okay, concept is what the basic concept used in this. We are taking one aqueous solution, and in that aqueous solution we are going to add less noble metal. Okay, less noble metal. And whenever a less noble metal is added in an aqueous solution of more noble metal, that less noble metal will replace that more noble metal. Okay, you are already aware about the what is the meaning of noble metal concept. Okay, whose vacancies are already satisfied. Okay, all its electron vacancies are satisfied. That is termed as the noble metal. And in that less noble or more noble metal will be, noble concept will be there. Less noble and more noble. More noble means its vacancy is very less. If suppose one electron's vacancy, or it needs one electron to satisfy its needs or fulfill its orbit, and if one atom needs two electrons to fulfill its last orbit, then that atom requiring two electron is less noble, and atom requiring one electron will be more noble. Okay, now whenever there is an aqueous solution of more noble metal and a lesser noble metal is added in that aqueous solution, then that less noble metal will replace that more noble metal. Okay, now I will tell you one practical example in this. Now, now if suppose CuSO4 solution is there, CuSO4, okay, copper sulfate, you can say that CuSO4 solution is there. If in that CuSO4 solution, if you add iron element, okay, if you add iron element, then what will happen? Iron is less noble than the copper, okay, which is present in that CuSO4 solution. Now that iron will replace that copper, means copper will get separated and iron will get combined. It will form a FeSO4 or any other compound of that iron with that SO4 atom. Okay, and copper powders or particles will get separated. So this is the process termed as precipitation from aqueous solution. Okay, in the same way, you can use silver. Okay, or you can take that. Another example I will tell you that, uh, suppose silver nitrate solution is there. Silver nitrate, in that silver will be more noble metal, and if you add copper or iron in that, they will separate the silver metal and you will be able to obtain the silver powder in this procedure. Okay, so in this way, this precipitation from aqueous solution principle is used for formation of the different metal powders. You can obtain copper powder, then you can able to obtain silver powder, then zinc powder, tin powder can be obtained here. And shape of the powders obtained here is a dendritic in nature. Okay, it will be dendritic in nature, means it will be having a tree like structure, tree or feather like structure. You can say that that is the dendritic shaped powder will be there. Tree like means one straight line will be there and some branches will be there, that is the dendritic structure. Or you can say that feathery like structure. In books the word used is the dendritic shaped powder is obtained in the precipitation from aqueous solution. Then the next chemical process of, used for manufacturing of the powder is intergranular corrosion. Okay, intergranular corrosion. Now in this intergranular corrosion, concept used here is, the boundary of any material. If any material is there, it will be having some grains and grain boundaries, and when it comes with in contact with the aqueous solution, then the grain boundary will corrode initially. Initially corrosion of grain boundary will occur, and after that the corrosion of actual grain will take place. That concept is used here in this intergranular corrosion. I will explain you with one example. If suppose stainless steel material is there, then that stainless steel material is taken and it is heated approximately at 500 to 800 degrees Celsius. And after heating to this high temperature, then this stainless steel is boiled in the aqueous solution containing CuSO4 and H2SO4, copper sulfate, and you can say that sulfuric acid, 11% CuSO4 and 10% H2SO4, and the remaining amount will be water. That we are going to boil that stainless steel, and due to this aqueous mixture, grain boundaries of stainless steel will get corroded, and automatically grains or the powder shaped particles of stainless steel will get separated, and generally whichever shape is obtained here, angular shaped stainless steel powder is obtained. Angular shaped stainless steel powder is obtained. Okay, this is the intergranular corrosion. Okay, the next is the reduction method. Now in the reduction method, here the suppose you want to form tungsten powder or molybdenum powder, their respective compounds are taken. Okay, like tungsten oxide or molybdenum oxide, there are some oxide compounds or halide compounds or formate compounds, respective compounds of that metal powder is taken, and these are reduced with the help of a suitable reducing agents like inert gases like hydrogen, or you can use carbon, ammonia, or carbon monoxide gases. Okay, just simply the reduction operation is performed, respective compounds are taken, and on they are reacted or their reaction is done with the reducing agents like carbon, hydrogen, like ammonia or carbon monoxide, and respective powder is formed. For example, you can say that if suppose tungsten powder you want to manufacture, and tungsten oxide is reduced, or a reduction of that tungsten oxide is done with the hydrogen gas, and at the end you will end up with the tungsten powder, and some water is formed. Okay, similarly molybdenum powder can be formed with the help of molybdenum oxide, and this molybdenum oxide is combined with the hydrogen, and at the end you will get the molybdenum powder formed, and some amount of water will be there. Okay, so this method is suitable for manufacturing of tungsten, molybdenum, then copper, then nickel, iron, or sometimes you can use it for manufacturing of chromium, zirconium, titanium, and tantalum or thorium. These large number of powders can be manufactured with the help of this reduction method. Okay, so these are three chemical methods which are used for manufacturing of the powders. Okay, which can be used for further manufacturing of the component by using powder metallurgy technique. Now the last type in this powder production is electrochemical process, or it is also termed as electrodeposition process. Electrochemical or electrodeposition process. Now in this method, just what is the concept here? We are going to use the aqueous solution, whichever powder you want to manufacture. Suppose aqueous solution CuSO4, or you can use the aqueous solution CuSO4. For example, you can take the CuSO4. Suppose you want to manufacture the copper powder. Okay, the aqueous solution is taken, and it's simply we are performing the electrodeposition process. Electrodeposition, or simply it is similar to the electroplating, means that aqueous solution is taken and high current is passed through that aqueous solution, then its respective atoms will get separated from it. Okay, respective atoms, either they will get attached on the cathode, either they will attached on the cathode, or directly they will separated or obtained at the bottom. Okay, electrodeposition, it is very similar to the electrodeposition process. A aqueous solution is taken, whichever powder you want to manufacture, its respective aqueous solution is taken, and high density current is passed through it. Okay, and we are going to obtain, due to that electrodeposition process, the respective metal powder is obtained. Here in this electrochemical process, the five factors we have to control, that is the current density, then metal ion concentration, then acidity nature of that aqueous solution, and the temperature and circulation of that aqueous solution, or you can say that the electrolyte circulation. Generally, you have to use the high current density and high acidity and low temperature and low metal ion concentration to get the desired shape and size of the powder particles. Okay, it is very similar. You can check that electrodeposition process. Okay, one aqueous solution will be taken, and current will be passed, high density current will be passed through it. Then the electrodeposition will occur in that aqueous solutions, means atoms or ions will get separated from that aqueous solution, and they will get deposited on the cathode. And from that cathode, we can separate that metal powder by slight rubbing operation. We will end up with obtaining the respective metal powders. Okay, so this is the electrochemical process. Now in this electrochemical process, powder can either directly obtained at the bottom after passing the high density current, or it will get attached to that cathode, and by slight rubbing operation you can remove that powder from that cathode. Okay, now in this electrochemical process, whichever shape of the powder obtained, it is a dendritic. Okay, dendritic shaped powder is obtained here. You can remember this precipitation from aqueous solution, and in electrochemical processes, shape of the powder obtained is dendritic. And example for this electrochemical process, you can able to attain copper powder, then you can nickel powder can be obtained, then beryllium, iron, zinc, tin, and then you can obtain the silver, lead powder with the help of this electrochemical process. It will give you dendritic shaped powder particles, and very high purity of that powder can be obtained in this electrochemical process. Okay, in this way, these are the different methods which are used for manufacturing of the powders, which can be subsequently used for manufacturing of the powder metallurgy components. Okay, depending on the shape and size of the powder particles required, you can select any suitable method. This is the first stage in the powder metallurgy technique that you have to use. Okay, this is the first step in your powder metallurgy technique. Okay, if you are having any query related to today's lecture, that is classification or different techniques used in the powder production or powder manufacturing methods in the powder metallurgy process, you can ask me. If all points are clear, I will stop here. Please mention that in the chat box or give me a reply whether all points are clear. If all points are clear, I will stop here. Wait. Okay, okay, thank you. You can continue with your next session.